Okay, so here at the end of this chapter on the contrapositive, we want to look at one more idea, which is actually not so related to contrapositives, but we kind of put it in at the end of this chapter, which is the idea of counterexamples. And so counterexamples come up a lot in math classes as like homework exercises, but we'll also talk about them in class from time to time, which is, sometimes we notice that an implication is not true. And the way that you show it's not true is by giving an example which shows it's not true. And we call this a counterexample, right? So for instance, let's look at the following, we'll call it a conjecture. Conjecture means we put forward a statement we think is true, but we don't know, we don't have a proof. So if P is prime, then 2 to the P minus 1 is prime. Again, it's a conjecture, meaning I don't know if it's true. I think this is true, seems reasonable. And so now we can either prove that it's true or we can look for an example that shows that it's false. And it's a statement about all prime numbers, right? So this conjecture is a statement about all prime numbers. Now, oftentimes in mathematics, we write things like this. If P is prime, then 2 to the P minus 1 is prime. And the quantifier is not so explicit, but it's implied here that we're saying for all. So another way of saying this is for all P natural numbers, if P is prime, then 2 to the P minus 1 is prime. And that at least gets you in, it makes it really explicit that we're talking about for all prime numbers. But the way I make it explicit, I have to say for all, or the way I said it is that for all P natural numbers, if P is prime. But another way of saying that, I could have said for all prime numbers, P, 2 to the P minus 1 is prime, right? So there's several ways to write this down. But what I want to make clear is that there is an for all lurking here, a quantifier for all, right? And so the point is that hence, if the conjecture is false, if you want to say that a for all statement is false, you just need to give me one example, because then it's not true that they're all case, right? So if you can just give me one example, then the implication is false. The for all implication is false, right? So if the conjecture is false, it would be enough to find one example of a prime P so that 2 to the P minus 1 is not prime. And this is called the counterexample. Don't, you should notice that it doesn't mean that there won't be other primes for which 2 to the P minus 1 is prime, right? So we're not saying that this statement is never the case for any primes, but remember that the statement that's being made is that for all P natural numbers, if P is prime, then 2 to the P minus 1 is prime. If that's false, you just need to give me one example which shows that the implication is not true, right? So, if you start playing around, you could check several numbers. For instance, if I start by checking 2, then 2 to the 2 minus 1 is 4 minus 1, which is 3. So that is true. So that didn't work, right? We can try 3. You get 2 to the 8 minus 1. Sorry, not 2 to the 8. Sorry, 2 to the 2 cubed minus 1. which is 8 minus 1, which is 7. So you see that it's not like a completely nonsense statement, because at least the first, let's try another one. The first few seem to be correct. 2 to the fourth is 16 minus 1. But now it doesn't work, right? Because let's just make sure. 2 times 2 is 4, 8, 16 minus 1 is 15. Yeah, and 15 is odd, but it's not prime, right? So this is not prime. And hence, that's it. It's not true. I mean, it might be true for even infinitely many prime numbers. I don't know, but it's certainly not true for all prime numbers. And so the statement is not true. Now, oftentimes when you find a counterexample, you may try to refine this statement so that it is true. Maybe you might say something like, well, for infinitely many primes, 2 to the p minus 1 is prime, which is not saying that for all primes. It's just saying that there's infinitely many of them. I'm not going to try to prove anything like that right now. I just want to say that when you find a counterexample, sometimes you can refine the statement and make that so that it is true. But if you're given a statement that has a for all a universal quantifier, then the way that you can show that it's false is just to give one example that shows that it's not true, and that is called a counterexample, right? So here we have found this is a counterexample, which shows that the conjecture is not true. And we will see a few more examples of counterexamples in the next video.